All right, question number 6 is first. An angle has a measure of 16 pi over 15 radians. What is the measure of the angle in degrees? This is the thing that we learned how to do on our remote learning day when we had Teams meetings, converting between radians and degrees. 16 pi over 15. If you want to convert that into degrees, you multiply by the fraction 180 degrees over pi. When you multiply fractions together, if anything is the same on top and bottom, they cancel out. So the pi on top here cancels with the pi on bottom here. And so then we multiply numerator to numerator and denominator to denominator. So I would have 16 times 180. What is 16 times 180? $2,880 is what I get from multiplying the tops together. Because the bottom of the second fraction canceled out, the only thing I have on the bottom of the fraction now is 15. And then I divide 2880 by 15. And what do you get? 192. So 192 degrees is what 16 pi over 15 radians is the same as. All right. Let's go look at part B now. Part B, we're doing the same kind of thing, but with a little extra thrown in. It says the measurement of angle R is 2 pi over 3 radians. The measure of angle T is 5 pi over 12 radians greater than the measure of angle R. If it says greater than, what operation are we going to be doing? Addition. So the measurement of angle T equals the measurement of angle R plus 5 pi over 12. And I know that the measurement of angle R is 2 pi over 3. So we're going to add 2 pi over 3 radians to 5 pi over 12 radians. I'm going to change both of those into degrees, and then we will add them together once we get them both in degrees. So first we want to do the measurement of angle R, which is 2 pi over 3. We're going to convert that into degrees just like we did on the last problem. We're going to multiply by 180 degrees over pi. The pi in the numerator and the pi in the denominator cancel each other out. So then I multiply numerator to numerator, denominator to denominator. What is 2 times 180? So 360 degrees over 3. What is 360 divided by 3? 120. So the measurement of angle R is 120 degrees. Now we just need to figure out what 5 pi over 12 is in degrees. So 5 pi over 12. Thank you. We're going to take that and we're going to multiply by 180 over pi. The pi in the numerator and the pi in the denominator are going to cancel each other out. And then I multiply numerator to numerator, denominator to denominator. What is 5 times 180? 900. So I have 900 degrees over 12. What is 900 divided by 12? 75. So this 5 pi over 12 is the same thing as 75 degrees. So we're adding 120 and 75 together. What do you get when you add 120 and 75? 195. So angle T is 195 degrees, which would be choice C. Absolutely fantastic. What else would you guys like to see? Number 24, very back page. Very last problem on the very back page. You guys actually had a problem like this on the skills check yesterday. So we're going to talk about how to do this problem. And if you missed this one on the skills check, pay special attention. We want to find the values of x and y, the measure of arc JK, and the measure of arc LM. Well, here is angle J, and here is angle K. And both of those arcs, both of those angles are intercepting the same arc. They're both intercepting arc LM. These are both inscribed angles because their vertex, their point, is on the circle. It's on the crust of the circle. Because these two angles intercept the same arc, they are congruent to each other. So I'm going to mark them as congruent. Angle J is congruent to angle K. So the measurement of angle J is equal to the measurement of angle K. The measurement of angle J is 3x plus 5. The measurement of angle K is 4x minus 6. And now we're going to solve this for x. So I'm going to minus 3x from both sides. That gives me 5 equals x minus 6. And then I add 6 to both sides. That gives me 11 equals x. And now while I'm here, I'm going to go ahead and find the measurement of arc LM. For an inscribed angle, the measurement of the angle is equal to half the measurement of the arc. These two angles, J and K, are the exact same size, so it doesn't matter which of these two angles I pick. So I'm going to use angle J. The measurement of angle J equals half the measurement of arc LM. And angle J was 3x plus 5. So 3x plus 5 equals 1/2 times the measurement of arc LM. And we figured out that x is how big? 11. So 3 times 11 plus 5 equals half the measurement of arc LM. What is 3 times 11? 33 plus 5 more? 38. So 38 is equal to half the measurement of arc LM. I want arc LM all by itself, but right now there's a 1/2 over there by it. How do I get rid of that 1/2? Multiply by the denominator. In this case, our denominator is 2. So we're going to multiply the right-hand side by 2. And if we do it to the right-hand side, we have to do it to the left-hand side. Multiply this side by 2. Denominator of 2 and the 2 on the right-hand side cancel each other out. So I just have 1 times the measurement of arc LM. What is 2 times 38? 76. So 76 degrees for the measurement of arc LM. Wonderful. All right. We still need Y and arc JK. So I'm going to erase most of the markings that I have on my picture. I'm going to leave those congruence marks. Y is right here as part of angle L and angle M. Well, here's angle L. What arc is angle L intercepting? JK. And angle M is intercepting that exact same arc. I'm actually going to do that in purple so that it stands out a little better. So because those two angles intercept the same arc and they're both inscribed angles, they are congruent to each other. So angle M is congruent to angle L. So the measurement of angle M is equal to the measurement of angle L. Angle M is 7x minus 1. Sorry, not 7x, 7y minus 1, my bad. Equals, and then angle L is 6y plus 3. And we're going to solve this for y. So the first thing I need to do is get my y's to the same side. I'm going to subtract 6y from both sides. That gives me y minus 1 equals 3. And then I add 1 to both sides, and I find out that y is how big? Y is 4. And now, just like on the last problem, we're going to find the measurement of arc JK. The measurement of the angle is half the measurement of the arc, because these are inscribed angles. Their vertex, their point, is on the crust of the circle. So I can pick either one of these angles. I'm going to go with angle M. Measurement of angle M is equal to 1/2 the measurement of arc JK. Measurement of angle M is 7y minus 1. So 7y minus 1 equals 1/2 the measurement of arc JK. And we figured out that y is 4, so I have 7 times 4 minus 1 equals half the measurement of arc JK. What is 7 times 4? 28 minus 1? 27 equals half the measurement of arc JK. And now what do I still need to do to get arc JK by itself? Multiply both sides by 2. Absolutely correct. If you do it to the right-hand side, we got to come over here and do it to the left-hand side. So the 2 in my denominator and the 2 that I'm multiplying by on the right-hand side cancel each other out. So now I have just arc JK by itself. What is 2 times 27? 54. So arc JK is 54 degrees. If we want just the angle, then you take either x or y and plug it in, and you're good. If we want the arc, you take either x or y, you plug it in for the angle, and then you double it for the arc. What else would you guys like to see? 22? Absolutely. Let's go up to the top side of this page. Number 22. This one says it has a part A, B, and C, but B has nothing, so that would be a typo. It says name 2 right angles. And up at the top, it tells me that AB and AE are tangent to circle C. When we have segments that are tangent to our circle, that means where the tangent line and the radius meet, so right here and right here, those are right angles. So this is a right angle right here, and this is a right angle down here. So angle ABC is a right angle, and angle AEC is another right angle. Using the measurements given on the diagram, find the lengths of AE, AC, and AG. So let's find AE first. AB is a tangent, and it has a length of 24. AE is also a tangent, and it's coming from the same point that AB came from. These two tangents then are congruent to each other. If two lines that are tangent to the same circle come from the same point, then they are the same size. So AE has a measurement of 24. All right. Now we want to find AC. Well, AC is this right here. That's not a tangent because it goes through my circle. It goes into my circle. A tangent just touches the edge of the circle but doesn't go into it, doesn't go through it. That's what we want to find. What is this shape right here? It's a right triangle. What can we use to find missing sides on right triangles? Pythagorean theorem, yes. A squared plus b squared equals c squared. What part of a right triangle has to go in for c? The hypotenuse. Of that yellow triangle that I shaded in there, what is the hypotenuse of that yellow triangle? AC, opposite my right angle. So this right here is the hypotenuse. So I'm going to put AC in the place of C. So what would go in for A and B then? 7 and 24. It does not matter which one goes where. One goes in for A, the other goes in for B. So we would have 7 squared plus 24 squared equals AC squared. I know 7 squared is 49. What is 24 squared? 576 equals AC squared. What do we get when we add 49 and 576? 625 equals AC squared. Now what do I do? Square root. If you do it to one side, you got to do it to the other side. The whole reason we're taking the square root is so that we can make the squared on AC cancel out. So the squared and square root cancel. What is the square root of 625? 25. So AC is 25. All right, last thing they want me to find is AG. Well, AG is just this bit right here. Is that the whole hypotenuse? No, it's the part that's outside of the circle. How big are the radii in circle C? 7. So how big is it from G to C? 7. Does anybody see what we need to do to figure out AG? 25 minus 7. What is 25 minus 7? 18. So AG is 18. What else would you guys like to see me work through? Number 3? 23, absolutely. Number 23. Finish out the back page. This is a quadrilateral, a four-sided shape that has been inscribed inside a circle. When we have a quadrilateral that's been inscribed inside of a circle, that means opposite angles are supplementary. So angles B and D are supplementary. They add to 180. Angles A and C are supplementary. They add to 180. Let's see what they've given us to work with. It says the measure of angle B is 102 degrees. So I'm going to write that in right here. 102 degrees. And the measure of angle D is 7x plus 1 degrees. 7x plus 1. Those two angles are supplementary. Measurement of angle B plus the measurement of angle D equals 180. Measurement of angle B is 102 plus the measurement of angle D, which is 7x plus 1, equals 180. I've got like terms to combine. I have 102 and 1. What do those combine to give me? 103. So 7x plus 103 equals 180. Then I'm going to subtract 103 from both sides. What is 180 minus 103? 77. And then I divide both sides by 7. What is 77 divided by 7? 11. So x is 11. All right. Got it. Then we have angle A is 4y plus 14 degrees. And angle C is 7y plus 1 degrees. The measurement of angle A plus the measurement of angle C is equal to 180. Angle A is 4y plus 14 plus angle C, which is 7y plus 1, equals 180. I've got my y's to combine. What do you get when you add 7 and 4 together? 11. So I have 11y plus, and then we have to combine the 14 and the 1 together. What does that give me? 15. So 11y plus 15 equals 180. Then I subtract 15 from both sides. What is 180 minus 15? 165. So 11y equals 165. Then I divide both sides by 11. What is 165 divided by 11? 15. So y is 15. All right, we have two arcs that we need to find now. I know it's an arc because it has that curved piece over the top, and an arc is going to be part of the crust of the circle. The first one they want me to find is arc BCD. BCD, this arc right here. What is the inscribed angle that intercepts that arc? Which angle is intercepting that arc? Angle A. Measurement of the angle is equal to half the measurement of the arc. So we have the measurement of angle A is equal to 1/2 times the measurement of arc BCD. Angle A was 4y plus 14. So 4y plus 14 equals half the measurement of arc BCD. We just figured out that y is how big? 15. So I have 4 times 15 plus 14 equals 1/2 the measurement of arc BCD. What is 4 times 15? 60 plus 14? So 74 equals half the measurement of arc BCD. Now what do I need to do? Times it by 2. We multiply by our denominator, which is 2. Do it on the left, do it on the right. The 2 in my denominator cancels out with the 2 on the right side, so I don't have a fraction and I don't have a 2 on the right side anymore. I do have 2 times 74 here. What is 2 times 74? 148. So 148 degrees for the measurement of arc BCD. All right. And then we have one more arc to go. This time, I want arc ABC. Here's arc ABC. What is the inscribed angle that is intercepting arc ABC? Angle D, yes. Measurement of the angle is equal to half the measurement of the arc. So I need the measurement of angle D is equal to 1/2 the measurement of arc ABC. Angle D is 7x plus 1 equal to 1/2 the measurement of arc ABC. We figured out that x is how big? X is 11. So I have 7 times 11 plus 1. What is 7 times 11? 77 plus 1? What is 77 plus 1? 78. So I have 78 equals 1/2 times the measurement of arc ABC. Now what? Times it by 2. Going to do it on the right-hand side to make our fraction cancel out. Going to do it on the left-hand side because if you do it on one side, you got to do it to the other. 2 and 2 cancel out, denominator and 2 that I'm multiplying by. So then I have 78 times 2. What is 78 times 2? 156. 156 degrees equals the measure of arc ABC. I have time for 2 or 3 more, depending on how long they are. What else would you guys like to see? Number 5? Absolutely, we can do number 5. Answer the questions below. Round answers to the nearest hundredth if necessary. For part A, they give us the circumference, and they want us to find the diameter and the radius. Remember, we have two formulas for circumference. Circumference equals pi d, or circumference equals 2 pi r, because the 2r is equal to my diameter, d. All right, so if I know the circumference is 53.5 centimeters, circumference equals, I'm going to use pi d here. Usually works out better on my calculator if I use pi d than if I use 2 pi r. The circumference is 53.5. So 53.5 equals pi d. And then we're going to divide both sides by pi. So you grab the yellow calculators. You'll put in 53.5 and then the division key, and then you're going to use the pi button. Don't use 3.14. Use the pi button right here. It's underneath the second key. What do you get when you do 53.5 divided by pi? 17.03. And we would pop centimeters on there because our circumference had the unit of centimeters. So 17.03. I know that the radius, diameter is equal to 2 times the radius. We figured out that the diameter is 17.03. That's equal to 2r. So then I divide both sides by 2. What is 17.03 divided by 2? 8.515, and we would put centimeters with that as well, equals our radius. All right, part B, they give us the diameter. They ask us for the radius and the circumference. So again, I know diameter is equal to 2 times the radius. The diameter is 12, so I have 12 equals 2r. Divide both sides by 2. What is my radius? 6. 6 centimeters for the radius. And then circumference equals, I'm going to do pi d since they gave us the diameter. So circumference equals pi times 12. I'm going to pop that into my calculator. I'm going to use the pi button and then times 12, or you can put parentheses around it. If you leave this in exact form, the first thing the calculator will tell you is that that is 12 pi, so 12 pi centimeters. But usually we want the decimal form. What is 12 times pi in decimal form? 37.699. And we would put centimeters with that. If the directions say something about rounding, like they did here, it says round answers to the nearest hundredth, you want to give your answer in decimal form. If it says it wants an exact answer or an answer in terms of pi, that's when you would leave it like this, 12 pi. But that's only if it says in terms of pi or exact. Other than that, we're probably wanting a decimal answer. What else would you guys like to see? I have time for probably one more. You said number 11? And which one did you say? 3 part B. If I have time, I'll go back and do that. Let's go look at number 11 next. Determine if LN is tangent to the circle. So what they're asking here is, does it make a right angle? What kind of a shape do we have here? We have a triangle, and we're trying to figure out whether or not this is a right angle. What can I use with right triangles? Pythagorean theorem, a squared plus b squared equals c squared. What's the hypotenuse of this triangle? Which one? 39, yes. So we're going to put 39 in the place of C. So what goes in for A and B then? 36 and 15. One in for 1, the other one in for B. Doesn't matter which is which. 36 squared plus 15 squared. What is 36 squared? 1296. And 15 squared? 225. What about 39 squared? 1521. We're going to add these two together. What do you get if you add 1296 and 225 together? 1521, which is exactly what we had on the other side of the equal sign. So these came out to be the same. So yes, LN is tangent to circle M because LN is perpendicular to NM. All right, let me see if I have enough time for number 3, part B. Yep, I've got enough time for 3B. So we'll end with number 3, part B. How big is chord WX? 4. How big is chord ZY? 4. So these chords are congruent. What does that mean about arc WX and arc ZY? They are congruent, yes. So the measurement of arc WX is equal to the measurement of arc ZY, because arc WX is congruent to arc ZY. Arc WX is 3x plus 1. Arc ZY is 2x plus 4. We're going to get our x's to the same side, so I'm going to minus 2x from both sides. That gives me x plus 1 equals 4. And then I'm going to subtract 1 from both sides. And I get that x is 3. If the chords are congruent, the arcs that they intercept are congruent. If the arcs are congruent, then the chords that are intercepting them are congruent. All right. Answer key is already posted in Canvas. You need to turn this in tomorrow, so please make sure you finish it up. Page, today's Canvas page, you scroll all the way down to the very, 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 very bottom, Geometry Module 10 Test Review Solutions. You click on this, and it will take you to all of my answers here. Also, I will be posting videos from all 4 sections of my geometry class. So if you had a question about one that I did not go over during this class period, check out the videos from the other 3 class periods.